Continuing on with our math of the engine, we're going to take a look at displacement and compression ratio and how to calculate both of those things. So for both displacement and compression ratio, we're going to need to know a bit about the swept volume. So lots of terminology coming at you again. So when I'm talking about the swept volume, what I'm referring to as your piston moves through the cylinder from bottom dead center to top dead center during one engine stroke, you are going to cover a certain volume. That volume will be cylindrical in shape, and we call that the swept volume. So some things we need to know. We talked about the bore, which is the diameter of the cylinder. And now we're going to talk about the stroke, which is like the height of the cylinder. Volume. We have a general formula for volume, which you should be familiar with after last term, and that's V for a cylinder equals pi r squared times h. Okay, so if we have that general volume formula, we can create a swept volume formula. I don't care which version you used. Pi. Now radius is going to be the bore divided by 2. Diameter divided by 2. You need to square that, which is to multiply it by itself. And then our height for our cylinder is going to be our stroke. So same formula, different variables. So let's do some swept volume calculations, knowing what we know now. Determine the swept volume of a cylinder with a bore of 3.5 inches and a stroke of 3.8 inches. So I'm just going to use I'm going to say swept volume, but I'm going to put down pi r squared h because that's what I'm used to. I don't care which formula you used. I know that the radius is going to be the bore divided by 2. And that will be 1.75 inches. I know that the height is the stroke, which is 3.8 inches. And now I have everything I need to find the swept volume. I'm going to use 3.14 for pi. You can use whatever you want on your calculator. If you use the entire button that it gives you, you'll have a slightly different answer, but it should be close. Radius squared times that height. Okay. So just putting in an extra step so we make sure that we see that when you do this, remember order of operations, you're going to have to do that 1.75 squared first, which is 1.75 times 1.75. So make sure you're getting a value like this on your calculator and then multiplying it by the stroke or height, which is 3.8. So our swept volume should be 36.542. If we are finding a volume, we start in inches and we end up with cubic inches. So either CI or IN with a 3 superscript after it. Let's look at another example. This time we're given the swept volume. So a little different. And we're given the stroke, which is like the height. And we want to find the bore. So we need to find the radius before we can get to the bore. So here we go. We're going to set it up, and I'm just going to fill in the formula with the stuff I know. So I know the swept volume. And I don't know the radius, and I know the height. I'm going to clean up, oops, I'm going to put a period in there so you can see it. I'm going to clean up the right side a little bit before I do any algebra. 29.83, which is 3.14 times 9.5. And I just leave that r squared. I want to get that 29.83 over to the left side, so I'm going to kind of divide both sides by 29.83, which will isolate my r squared. I end up with r squared equals 27.82. If you have a square, in order to undo that, you're going to find the square root of both sides. That's just a button on your calculator. R is about 5.27 centimeters. So what's the bore? you got to double that to get the diameter. And we're going to get 10.55 centimeters. So going backwards. So now that we know how to find the swept volume, we're ready to find the displacement, which is not hard. So the swept volume is for a single cylinder. So all you have to do to find the displacement of an engine is multiply your swept volume by the number of cylinders in that engine. So if you had, let's say in the other example, we had something that was about 36.5 cubic inches, and let's say that was in a 4-cylinder engine, then you'd be like this. So our displacement in cubic inches is simply going to be 36.5 times 4 gives us 146 cubic inches. Now, commonly we see liters as an expression of displacement, you know, 3.5 liter engine. You might see cc's as well. So we really want to know how to move around this. So if I have 146 cubic inches and I want to go to cubic centimeters, I'm going to multiply that. You can use any formula sheets, you can use any online calculators, whatever floats your boat. And I'm going to get about 2392.5 cubic centimeters. That's one way to express the displacement. Another way is to put it in liters, which is what we're used to. So we take cubic centimeters and we divide by 1,000 to get to liters. And that gives me 2.3925. I'm going to round that because you often hear it with one decimal place, 2.4 liters. So everything in yellow here is the displacement of the same engine, just expressed in cubic inches, cubic centimeters, and finally in liters. So we're going to do an example from start to finish now. Find the displacement in liters, so there's going to be some conversions. It's a V8. We know we're going to be multiplying our swept volume by 8 to find the final displacement. We have a bore in millimeters and a stroke in millimeters. So we need to find the swept volume, first of all. I need a radius. I'm going to get that from my bore. I'm going to take that 97, and right away, I know that we don't work in cubic millimeters, so I'm going to change 97 millimeters into 9.7 centimeters by dividing by 10. So there's our bore. We need to divide it by 2 to get a radius, and I'm going to get 4.85 centimeters. Okay. The stroke is the height of the cylinder. And if it's 86 millimeters, I'm going to make it 8.6 centimeters. Here comes the swept volume. Pi r squared h. Same formula every time on your formula sheets. 3.14 times 4.85 squared times 8.6. And the swept volume for one cylinder is now going to be in cubic centimeters because I put centimeters in, centimeters out. Or we could say cc. I'm inconsistent. Okay, knowing the swept volume for one cylinder, I can now find the displacement of the engine. Displacement equals swept volume multiplied by the number of cylinders. So in this engine, it's going to be 635.2, the swept volume, multiplied by 8. And that's going to give me 5081.6 centimeters cubed. They wanted this question answered in liters, so give them what they asked for. You're going to take your 5,000 and change cc, you divide it by 1,000, 5.0816 liters, round it to one decimal place, let's say 5.1 liters. That engine has a displacement of 5.1 liters. Make sure you get the terminology and know how much work you actually have to do. Here we're looking for the displacement. We know the number of cylinders. We don't have to find the swept volume. They already gave it to us. This is a sweet question. All I have to do to find the displacement is take the swept volume and multiply it by the number of cylinders. And you'll notice I'm back and forth with using the X for multiplication or brackets. Same. It's because I work in trades and sometimes I work in more mathy stuff. So I'm inconsistent, just bear with me. All right, if I do that math, I'm going to get 2097.88 centimeters cubed. Now, if I want that in liters, once again, I'm going to divide it by 1,000. That's my conversion, and I'm going to get 2.1 liters. Another question on finding displacement. So we've got a V6 engine and we get born strokes. We're committing to the entire process. So we are going to take a swept volume is going to be equal to pi r squared h. And I'm just going to be a little quicker. 3.14. If my bore is 5.24, I'm going to divide that by 2 and get a radius of 2.62. So that's coming from here. And my height is my stroke, 6.62. And that's going to give me 142.7, and I'm in cubic inches here. All right, so what are we going to do? We're going to get that to cubic centimeters. We multiply by 16.387, that's my conversion factor, to make cubic centimeters. Our swept volume in cubic centimeters will be 2338.2 cc. Let's do it in liters because it's going to be big. And we divide by 1,000 and we get 2.34 liters. Okay, so that's a swept volume. So we're looking at a big engine here. We're probably looking at a big diesel engine. So we still need to get the displacement. So we're going to take our swept volume. I'm already in liters. And I'm going to multiply by the number of cylinders. And I'm going to get my final displacement when I do all my rounding, 14 liters. Big engine. For the second part of the question, we're going to bore the engine 0.05 inches oversized. What does that mean? It means we're going to change the bore from 5.24 inches. We're going to add the additional diameter from boring it out, and we're going to get 5.29 inches for our bore. So nothing changes, the stroke stays the same, pi never changes, but we are going to change the radius because we changed the diameter or the bore. Okay. Swept volume 3.14. This time we're going to take 5.29 and divide it by 2, which means our radius changed to 2.645. Doesn't seem like a lot of a change. We'll see what happens. And we're going to keep the same stroke, 6.62. Okay. When I do all that math, I end up at 145.4 cubic inches. Multiply it by 16.387, and I'm going to get 2383 cubic centimeters, which is 2.38 liters. And now I'm going to find the displacement, 2.38 liters times 6, and it gives me 14.3. So a bit of a change from that. A little bit of boring, bigger displacement. All right, to summarize our steps to getting to the displacement, when you start out and you're given a bore and a stroke, make sure you change that radius, that bore to a radius rather, by dividing it by 2. Remember to do any conversions if you need to. You will kind of want to be in centimeters or inches before you start. Okay, you're going to take that radius and you're going to put it into the swept volume formula, and you will get the swept volume of one cylinder. Now, things to remember here, square that radius before you multiply by pi and the stroker height. Take your swept volume, you're going to multiply it by the number of cylinders in the engine to find a displacement. Now, you might be in cubic inches, you might be in cubic centimeters. It depends on what the question is asking. If they don't ask you for liters or a specific unit, you can leave it in whatever you found it as. But if you need to change it to liters, remember to do that conversion at the end for full marks. Moving on. compression ratio. You've probably seen this before in your shop classes, but let's just take the free marks and do it again. So what we're doing when we're talking about a compression ratio, we're comparing the volume in the cylinder when we are at bottom dead center and we have lots of volume, to top dead center when the piston is at its maximum height and the combustion chamber or the cylinder volume is very, very small. Okay, so we call this situation where we see the red when we're at top dead center, this is the clearance volume. Okay, and if we looked over here, we see you have V1 and V2. So we know that V1 was that clearance volume. V2 should look familiar. We just did a bunch of stuff calculating it. V2 is our swept volume. Okay. When we compare these, we would get two different numbers. But if we divide the blue situation by the red situation, we end up with a ratio that is, to 1. And if we're thinking about when we're at bottom dead center and we want to get the entire volume here, we're just going to do swept volume plus clearance volume. So what goes into the clearance volume? Swept volume, we already know how to calculate. We're going to have the combustion. So here we have our head, here we have our block, here we have a gasket. So we have a combustion chamber volume right here. I'm going to call that CCV for combustion chamber volume. Now, this will usually be given to you in cubic centimeters, so you don't have to do a lot of work. The other one that's going to be given to you in cubic centimeters is the piston relief volume. Most likely given to you in cubic centimeters. These are because they're not shapes that we can calculate. Like if you look at the top of a piston and it has some kind of variation with it, it might be a swoop where the valve can fit in, it might be a crazy dish thing going on for a diesel engine. Same with the combustion chamber volume. It's not going to be a perfect hemisphere. It's going to have some features to it that increase swirl or whatever. So they have to just give us that volume. We're not going to use calculus to find it. However, the head gasket volume, HGV, right here is another cylinder. It's a very tiny cylinder, right? So you can use V equals pi r squared h, where you're just going to have the h be this little piece right here. Likewise, the deck height volume happens here. It's another cylinder shape, and it represents when the engine is at the piston is at top dead center, if there's a little bit of space still left between the top of the block or the deck and the top of the piston, it will be cylindrical. Okay, so this is just really a pain in the butt of calculating little things. Here's another picture, just trying to show it. So as we move through our stroke here from bottom to top dead center, when we're at top dead center, we end up with that combustion chamber volume, that deck height volume, the gasket volume, and if there's any kind of action going on, you'd get piston relief volume. Okay, so back to how we're going to find this compression ratio. So you need to find the clearance volume, and then you are going to find your compression ratio. So compression ratio is the big number, the volume at bottom dead center, compared to the little number, the volume at top dead center. And you are going to do that math to get that kind of ratio to 1. Okay. When you're at bottom dead center, you have your clearance volume and you just add in the swept volume of the cylinder. So here it is as the final formula. It'll be on your formula sheets. Take the swept volume, add the clearance volume, do that math first. Once you get your answer, divide by the clearance volume to get your compression ratio. Let's do an example. And this is what every single one of these questions will kind of look like. So as we go through, if you've got this example down, you've got them all. And this is a more annoying example as well, where the bore and the stroke are given to you in inches instead of centimeters. So I'm going to work in inches. I'm going to convert the piston relief volume and the combustion chamber volume into cubic inches. That's just what I'm going to do. It doesn't matter which way you do it. It doesn't matter if you're converting to centimeters, or cubic inches. You should get the same compression ratio. All right, so things I need to know. I'm going to go use the bore and the stroke to find the swept volume. So that will be in black. Pi r squared h. The bore is 4, so the radius is 2, and the stroke is the height in this situation. And that should give me 36.05 cubic inches. I'm going to set that aside. Okay. Next, I'm going to look at the other two cylinders, which are going to be the deck height volume and the head gasket volume or thickness volume, whatever. Okay, so I'm going to do this one in red. You could add the deck height to the head gasket thickness and do it all at once. That's totally fine. I'm just going to break it down. So deck height volume. Same thing, pi. Our bore is the same, but we get an itty bitty height for the cylinder. And my rounding will be inconsistent, as it always is. Okay, let's do our head gasket thickness in orange. So I'm going to call that the HG volume, head gasket volume. Pi is the same. Bore is the same. The height of the cylinder changes. And that should give us about 0.57 cubic inches. All right. Next, I'm going to deal with the combustion chamber volume. I am going to divide it. I'm going to take my cubic centimeters and I'm going to divide it by 16.387, and that will make cubic inches. Okay. When I do that math, I get about 3.54 cubic inches. And then finally, like I'm running out of colors here, what haven't I done yet? Well, you do the crazy lava pen. The piston relief volume, same thing. Divide it by your conversion factor. And I'm going to get 0.56 inches, cubic inches. Okay, that's everything I need. So what is going to go into my clearance volume? Everything except the swept volume. So you're going to add up this number, this number, this number, and this number. Your clearance volume is going to be equal to 4.77 cubic inches. Now you're ready to find the compression ratio. Your compression ratio is equal to the swept volume plus the clearance volume. That's the volume of your combustion chamber at bottom dead center, or your whatever cylinder. My lingo's so bad. And you're going to divide that by the volume of your combustion chamber at top dead center. Okay, so we said the swept volume was 36.05. We're going to add the clearance volume, 4.77. Put that in brackets so you know to do it before the division. Okay. When you do that math, you're going to get 8.56. So what that means is your compression ratio, 8.56 to 1. Most of the questions you would ever get would be like the previous slide, but just in case, remember, you need to know your way around something. So if they tell me the displacement is 15.3 liters, and I want to find compression ratio. I know that displacement is not useful to me, but I know that the swept volume is going to be the displacement divided by the number of cylinders. So I'm going to take 15.3 and I'm going to divide it by 6. That'll give me about 2.4 0.55 liters. Now, liters, not particularly useful to me in this question, so I'm going to change that to 2,550 cc. What did I do? I just multiplied by 1,000. Okay, so that's my swept volume. Now I need to think about, I'm going to have to calculate the clearance volume. No, thank you. They gave it to me in cubic centimeters. So my swept volume and my clearance volume have the same unit. I'm good to go. So we're going to find the compression ratio. Swept volume plus clearance volume divided by clearance volume. Bottom dead center volume divided by top dead center volume. Okay, so where did we put that swept volume? There it is. Here's our clearance volume that was nicely given to us. We divide by the clearance volume, and we're going to get a compression ratio of about 17.46, which means 17.46 to 1 is the ratio. You can tell I was teaching a diesel class last term.